Hi everyone, welcome back to Algebra 3. Today we're going to be looking at functions, their characteristics, and we're also going to use some technology as we do these. So we'll be finding increasing and decreasing domains first. Okay, so first of all, you have some questions about increasing and decreasing intervals, and you'll notice you can either type them in as intervals or as inequalities. So let's talk about first what it would mean for a function to be increasing. A function is increasing if, as the x values increase, the y values also increase. So the x values increase. If you look at the number line, the x values are increasing as we move from the left to the right. So as the x values increase, meaning as we move from left to right on the graph, the y values increase, meaning that the y values of the points would increase. So in other words, that's the part where the graph goes up. So I'm looking on my graph where the graph goes up from left to right, and I'm going to list the x values where that happens. So to find, I'm looking for increasing. Okay, so to find the increasing, I'm going to jump on the left side of my graph. I'm going to trace it from the left to the right, and I'm going to look for the part where my pencil starts to go up. So my pencil's going down, 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 down. Then right here, it changes and starts going up, 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 up. So this part right here, this is the increasing part. And it starts increasing at the point -1, -2. And then it increases forever and ever until infinity. All right, so if I'm listing the x values, then I'm going to say it increases from x equals -1 until infinity. So I will type in from, and we're going to use brackets here, from x equals -1 until infinity. But we don't use a bracket on infinity. We always use parentheses because infinity is not really a number. It's more of an idea. There we go. So let's try the next one. Now we're looking for decreasing intervals. Let me change colors here. Decreasing. Already got increasing listed up there. Decreasing as the x values increase, the y values decrease. So that means as we move on the graph from left to right, the y values decrease, which means that the graph would go down. And again, we're going to list x values for this as well. So hop on the left side of the graph, trace it, and I'm looking for where the graph goes down. So the pencil's going up, 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 and then going down, 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 down. So where does it change? Looks like it changes right here at the coordinate 4. That's hard to tell. I'm going to guess about 97. Until, no, this does not have an arrow on it. It stops. So until 11, 0. So I list the x value. So it looks like the function decreases from x equals 4 until x equals 11. So I will type that in using brackets on both. And I will check my answer. There we go, decreasing. Okay, so then to find maximum and minimum values with technology, I'm going to need my graphing calculator for this. So find the maximum value of the function, and they give me a formula to the nearest hundredth. So the first thing I'm going to do is I'm going to graph that formula, just typing it into Desmos. 1.8x squared, 7x, minus 11. I know it's quadratic, so we should be seeing a parabola, so I want to get a good picture of it. And parabola is only, that's a parabola. Okay. I want to find the maximum value. Well, the maximum value of a function, when it says the maximum value is the highest y value. If they want to know the minimum, you would say the lowest y value. Now Desmos makes it really nice because to find the highest, the maximum, all I have to do is just click on it. And the highest y value is negative 4.194. And they want the nearest hundredth, which is 2 decimal places. But if I need more, I should on Desmos be able to just zoom in. All right, so my highest y value would be negative 4. Hundredth is 2, so 19. There we go. The next one is asking me for the minimum value, so let's go ahead and do that one. I'm going to type in that formula. F of x equals 0.2x squared minus x plus 5.2, and I'm double checking to make sure I've typed in everything correctly. It's oh no, I did not. There we go, 0.2x squared minus x plus 5.2. If I ever get lost in my graph, I can always press this home button. And then I see it's quadratic, so I know I should be seeing a parabola. There's my parabola, and I want to see the lowest point, which looks like it's right there at 3.95. So I'll type in 3.95, and that's correct. Then the next part, you have to worry about finding even and odd polynomial functions. Even and odd is dealing with the sign. So here's how you tell. You have to substitute in negative x for x. So substitute in negative x for all of the x's. If you get something that is the same as the original function, it will be even. If you get something that is totally opposite, all of the signs, every single one of the signs are opposite, you'll have an odd function. If you get something that's just different, maybe some of the signs are opposite, but not all of them, we'll call that neither. All right, so here's my original function, f of x equals x to the fifth minus x cubed minus 6x. I'm going to substitute in negative x for all the x's. So that I'm going to copy this down, copying down this formula, but instead of x's, I'm putting parentheses. So parentheses to the fifth minus parentheses to the third minus 6 times parentheses, and inside those parentheses, I'll put negative x, and then I will simplify everything. So this equals, okay, negative x to the fifth. Well, x to the fifth is x to the fifth. And then when you raise a negative to a fifth power, that means you're going to multiply a negative times a negative times a negative times a negative times a negative. And we know that a negative times a negative is a positive. A negative times a negative is a positive, but then you have a positive times a negative to be negative. So negative x to the fifth. Minus negative x cubed, that would be x cubed, but then negative would be negative x cubed. Then negative 6 times negative x is positive 6x, because negative times negative. And I have a negative negative right here, so it looks like I get negative x to the fifth plus x cubed plus 6x. So I'm going to compare the signs of this to the original. I've got negative x to the fifth and positive x to the fifth. Those are opposites. Positive x cubed and a negative x cubed. Those are not opposites. Actually, yeah, they are. opposite, and opposite. Just kidding. And then negative x to the sixth, positive x to the sixth. Opposite. So it looks like all three signs are completely opposite, which would mean that this function is odd. There we go. Let's try another one. Okay, got to determine if it's even, odd, or neither. When you're doing these, a negative to an even power is going to be positive, and a negative to an odd power is going to be negative, just for reference. All right, so here let's find f of negative x. Negative x to the 7th power plus 4 times negative x to the 3rd power plus 5 times negative x to the 5th power. All right, so this equals negative to the 7th is negative x to the 7th, but then there's a negative out front. Negative x to the 3rd, that's a negative to an odd power, which is negative. So negative x cubed times positive 4 is minus 4x cubed. And a negative to an odd power is a negative times 5, minus 5x to the 5th. Right here I have a negative, which is positive. So let's compare everything. I had negative x to the 7th, now I have positive, those are opposites. 4x cubed, negative 4x cubed, those are opposites. Positive 5x to the 5th, negative 5x to the 5th, opposites. Since they are all opposite signs, this will be an odd function. All right, now let's find even and odd functions from a graph. Okay, so the function f of x is graphed below. Determine whether the degree of the function is even or odd and whether the function itself is even or odd. All right, well, the first thing, the degree of the function. Degree of a function is that highest exponent. So like if I have f of x equals x cubed plus 7x squared plus 2x plus 1, the degree of this function would be 3 because the highest exponent on the x is 3. So, and 3 is odd, so this would be an odd degree. Now, we don't have the formula, we have a graph. So there's another way that we can tell if a function has an even or odd degree. So a function would have an even degree if either both ends of the graph point up, doesn't matter what's happening in the middle, or both ends of the graph point down. It would have an odd degree if one end points up and the other one points down. And it could happen either way, either left down and right up, or left up and right down. So from this picture, both ends are pointing, the arrows are pointing opposite directions. So I can tell you right now that this graph has an odd degree. Okay? Now, is the function an even function or odd functions? Well, even functions, f of negative x is equal to f of x. So let's see, is f of negative 2 the same as f of 2? I'm just picking, so you can pick any number for x that looks like it would show up on the graph and compare those values. So I look at 2, f of 2 looks to be about negative 40. F of negative 2 looks like it's about positive 40. Those are not the same, so this function is not even. Okay? Maybe it's odd. For odd functions, f of negative x is equal to the opposite of f of x. So for this, if I use 2 again, f of negative 2 would be equal to the negative f of positive 2. So let's see what happens. We said f of negative 2 is about 40. and then f of 2 is negative 40, but there's a negative in front, so negative 40 is positive 40. That's true. So this function is odd. Now, if you were to get two totally different numbers, you would say neither. So it looks like this function has an odd degree and is odd. So I'm going to pick this function has an odd degree and is odd. So I'm going to submit, and there we go. Let's try another one. This function, both ends are pointing the same way. So I'm going to say this is even degree. I'm writing with a mouse, I have no idea why. Even degree because both ends are pointing the same way. Now let's check if it's an even function. So is f, let's see if it's even function. So is f of negative x the same as f of x? Well, let's see. It looks like I can pick negative 1. Is f of negative 1 the same as f of 1? F of negative 1 looks to be about negative 10. And f of 1 about the same, maybe not quite negative 10, but they're in the same place. We're going to estimate about negative 10. So it also looks like it's an even function with an even degree. So I'm going to select that this function has an even degree and is an even function. Yes. And there we go.